Hi everyone. Today our topic is about synchronization. Synchronization is generally implicit in memory passing models since a message must be sent before it can be received. However, in shared memory, unless we do something special, a new receiving thread will not necessarily wait and could read an old value of a variable before it has been written by the sending thread, usually implemented in either model by spinning or blocking. Next we will look concurrent programming fundamentals. Schedulers give us the ability to put a thread process to sleep and run something else on its process or processor. Six principal options in most systems. So this portions is already asked in previous question papers. So we will look what are the six principles: co-begin, parallel loops, longit elaboration, fork, implicit receipt, early reply. What do you mean by co-begin? This allows a set of operations to be performed at the same time. Okay, a set of operations to be performed at the same time. So co-begin statement 1, 2, we can see up to statement n end. Here we can see this allows a set of operations to be performed at the same time. Each statement is usually a subroutine call but can be any sequential or parallel compound itself. Then we look what is parallel loops. Specifies a loop whose iterations happen concurrently. For example, in OpenMP for C, 4 int I is equal to 0, I less than 3, I plus plus printf thread. Okay, in C sharp, it can be parallel 4.403 I is equal to or equal to or greater than then console dot write line. Okay, this is a loop whose iterations happen concurrently. So this is how in OpenMP for C or in C sharp, it is how it is implementing. Next is longit elaboration. What do you mean by longit elaboration? In some languages, code for a thread looks like that of a subroutine with no parameters. When the declaration is elaborated, a thread is created to execute the code. In ADA, where threads are tasked, procedure P is task T is up to end T, then begin P, end P. Task T has its own block, which begins to execute as soon as P is ended. If P is recursive, there may be many copies of T operating concurrently. When end of P is reached, it waits for its copy of T to end before leaving. Next is fork or join. Fork is more generally than last three examples, makes the creation of threads an explicit executable task. Join is the reverse operation which slows the thread to wait for the completion of previously forked thread. Java syntax where we need inheritance. Class image render extends thread image render arguments. It is a constructor. Then public void run got to be run by the thread. The thread is started not at creation but when the method start is called. Note that this requires run to be defined. Then other variants. In C sharp, thread classes don't need to inherit. Instead, one can be created from an arbitrary thread start delegate. So class image render, we can see public image render arguments is the constructor and the public void view is the code to be run by the thread. Then you can see image render is equal to new image render arguments, thread rend is equal to new thread start rend object dot view. This is how it is implementing. Then other variants in the new language Click recently developed at MIT and licensed to a private company, threads are simply created by the call spawn. Here can be spawn any function arguments. Later the built-in operation sync will join any threads. Language includes built-in support. So these are all about our topic of concurrent programming fundamentals and synchronization. I will come with the next topic in the next video. Till then, bye.